This is WebDev Sumos, and today we'll be solving questions from array and hashing set. And yeah, it's a new time that I'm trying to do the lead code. I'm not like I'm going to focus on my health as it's I've been neglecting it for over a year now. So I've decided to work out early in the morning and then probably do the lead code somewhere in the middle of the day or later in the day. So yeah, that's what the plan is, and I'll continue solving some questions. So I'll be doing a few of these questions like the I guess I have done this one design hash set. Oh, not design hash set. I've designed hash map. I've done that. But yeah, what we want to do is now remove elements. Okay, we'll see what it is, and we'll try to implement that. Okay, let's time ourselves and let's get started. So the question is, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The order of the element may be changed, then return the number of elements in nums which are not equal to val. Consider the number of elements in nums which are not equal to val bk. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the elements which are not equal to val. The remaining elements of nums are not important as well. Okay, let me see. Oh, it I guess this question is similar to the remove zeros. So what we have to do here is consider we have to consider two pointers which will say one pointer will always be pointing at the index where the where a value will be stored which is not equal to the uh, value like the target just so in this case 3223 is given, right, and we have given the value to be 3. So whenever we see a 3 will okay, so this is we'll take the second example. Here the value is 2, so we have two pointer. Let's say let's you know what, let's go to the Miro board and let's try to do it there. It's been a while we haven't used Miro board, so let's use that. And yeah, uh, where is my Miro board? I have it here. Let's go back. Mm, yeah, just give me a second. Okay, so my Miro board is here. I'm opening it up. Let me pull that up on the desktop as well. Miro board. Whoa, that's a bright screen. Okay, so we have this. Let me get rid of whatever is there on the screen and delete this. Okay, so we have this, and let me just copy down the array that was there. Yeah. So we had 0, 1, 2, 3. Sorry. 0 1 2 2 3 0 4 2, and yeah, and the value is 2. Let's go back, and once we see that, okay, so we can see that 0 1 2 3 is there. As discussed, I will have a ith pointer, and jth pointer will be pointing at this, and there will be one pointer that will be moving, like we'll use to iterate all the elements. And let me just index them. Okay, so yeah, let's say we are using ith pointer to iterate through all the elements. And what j will do is j will point um, at the index where we will store elements which are not equal to 2. Okay, so j will be pointing at the valid index, where the elements which are not equal to the value will be storing. So so the I is pointing at 0. So yeah, what we'll do is we'll swap I and jth position. So basically 0 will remain as is, and then I will, sorry, my bad. Wait a minute. I'm trying to, so I will back, back. What I'm trying to do is select this. Yeah, I will go here. Yeah, once I will go here, it sees that j, like it is not equal to the value. Then I will go here, and j will also be incremented along with it. Yeah, yeah. J will be also incremented along with it. So j will be also here. And then when actually I and j will be moving together. Yeah, I and j will be pointing here. So once we identify 2, then what we'll do is we'll keep moving I, and j won't increment. And here on the third index, it's again 2. So what we'll do is we'll again move this guy to 3. Now that we have seen a value which is not equal to 3, we'll swap these both items. So I will go to, like, this. Let me fetch this. 3 will go to the index 2, and let me just rub it out, or yeah, and here 3 will come, here 2 will go. Let me rub this, yeah, and basically the jth pointer will increment. Okay, we swapped the elements, and then we are incrementing the j to the its original spot. Like whenever we identify an element which is not equal to the value, we'll put that element to the jth index. So I will, sorry, let me keep, yeah. So then I will keep moving here. So 0 will come, 0 will again be shifted to the jth position. Um, like so we had 0 here and 2 here, and j would again be incremented to this spot. Yeah, and then I will be also incremented here. Then it's again we identified an element which is not equal to value. We'll again swap those elements, 4 and 2, right? 4 and 2, and we'll also increment the j and an I, and we keep on incrementing it. So we finally will have the all the values, all the elements which are equal to the value given to us will be at the end of the array, and we can return the return the nums. So basically, let's code it out. I is equal to 0, j is equal to 0 as well, and then for let I is equal to 0, I is less than nums dot length I plus plus. Then what we have to do is, if I is equal to if nums of I is not equal to value, that time we have to kind of swap nums of I with nums of j, and we also have to nums of j plus plus increment the jth value, and nums of I, okay, we have to do that, and yeah, that should be it, and basically return nums, right? That's what we have to. Your function should return k is equal to 2. Oh, k is equal to 2 with the first two elements of nums being 2. It does not matter what you leave beyond the returned k. So what we can return is the value of j minus 1. Can we do that? J minus 1. I guess we can do that. 0, 1, 2, 3, 4. Or yeah, we can just return j. Yep, we can just return j. Hopefully that should work. Why is that? I is equal to 0. Okay, let's keep it this way. J plus plus. Oh, okay. We don't have to define I here. Yeah, so see, this is working, and nums can be equal to 0. So let me add a test case where the array that has been given to us is equal to 0. Then what happens, I'm not sure. Okay, so either ways it's working. Yeah, so the time complexity is O of n and space is O of 1 for this one. Like this, store this is in this question in array, and let's check out the companies that have been asking this question. Quite a lot companies like to ask this question, god knows. Yeah, it's pretty simple, but yeah, there is a trick to it. This is the trick, kind of to implement it that way. But yeah, let's keep and let's see if we have already solved this. I guess, yeah, I have already solved this question in last year 2022. Okay, let's check works this, star mark this question, and let's hop to the unique email addresses. Okay, what that question is about, let's check it out. Okay, okie dokie. Alu Loki. Okay. So we have unique email addresses, and looks like, and let's read the question, what it's trying to say. I'll just zoom it a little bit so that you guys can see it. Every valid email consists of a local name and a domain name separated by the @ sign. Local name and domain name. Yeah, that's true. Beside lowercase letters, the email may contain one or more dot or plus sign plus. Okay. For example, Alice at leetcode.com. Alice is the local name, leetcode.com is the domain name. If you add a period between the last between some characters in the local name, if you add a period between some characters in the local name, part of an email address, mail sent there will be forwarded to the same addresses without dot in the local name. Note that this rule does not apply to domain names. For example, alice.c at leetcode.com and alice.z at leetcode.com forward to the same email address. Okay, got it. If you add a plus in the local name, everything after the plus sign will be ignored. The, the, this allows certain emails to be filtered. Note that this rule does not apply to domain name. For example, m.y plus name at email.com will be forwarded to my email.com. It is possible to use both of these rules at the same time. Given an array string emails where we send one email to each email of I, return the number of different email addresses that actually receives mail. Oh, okay. Um, so if I understand this question correctly, they want to identify unique emails as the name suggests, and based on the two conditions that they have given us, we have to kind of uh, it's basically string validation. We have to validate kind of or what do we say, sanitize, yeah, sanitize the string according to the given condition, and then probably store it in the map. Yeah, yeah, we have to store it in the map and return the map size eventually. Yeah, oh, that's what I think I should be doing here. So let's see the examples that are here. Mails test.email plus Alex. So test email and whatever is after plus it will be ignored, right? Yeah. So test email is 1 at leetcode.com. Test dot dot mail is 1, uh, and whatever is after plus will be ignored at leetcode.com. So this is these both are same, test email plus these both. Okay, at leetcode.t code.com. Okay, so these two are similar and the last one is different. So yeah, that's how we get to, and here everything is different. So but a basic intuition is the low, as they have suggested, is local name and domain name are the two um, are separated by at the rate, right? So why don't we just separate those two guys on the basis of at the rate symbol, at symbol, and so we'll have local and domain names with us. And once we have that, then what we'll do is um, we'll see um, what we'll do is we'll see if plus is there in the string, in the local string or not. if it is there, then we'll find out the index of it and then grab whatever is before the plus index, right? Yeah, whatever is before plus index, we'll grab it. And once we have done that, we have to basically get rid of all the dots that are there in the string, so that we have just the letter, we have just the characters. So yeah, that's what we gotta do. It's pretty JavaScripty question, I would say. But yeah, cool. So let's try and do it. I'm not sure if, yeah, the questions to ask to interviewer would be related to email. So they said everything will be in lowercase. So I am expecting it to be lowercase, and there will be always emails in the array as the constraint says. What else? Yeah, there is also length. Yeah. Okay. So there will be only one at symbol. Yeah, we should be asking such questions, but yeah, like not just jump into the actually solving the question and get lost in it, but actually asking the edge cases is a good idea. So const map is equal to new map. We have this, right? We have this, and lastly we have to return this. Return map dot size. Yeah, this would be the answer. So map dot size, yeah, this would be the answer for our question. What we need to do is we need to basically separate those let local and domain. Can we destructure it using emails dot, okay, sorry, we need to basically first let email of emails. We have to basically traverse all the emails, and then what we can do is let local and domain, or domain name, will get those from splitting the email on the basis of at symbol. Yeah, once we do that, we have our local with us. What we need to do is check if plus symbol is there in local. Okay, so how can we check that? Local dot index of plus, if it is greater than -1, yeah, then it is available, right? Or let's do this, let or const index of plus is equal to this guy. If index of plus is there, then we know that we have to take the string which is available before the plus sign. So can we do this? Let or const before plus is equal to local dot substring 0 to index of plus. I guess if we do this, we'll sorry we'll get a we'll get the I'm not sure. Yeah, we'll get the string which is there two voices coming? Oh, yeah, once we do that, we'll get the two we'll get the string. Minimize this, sorry, yeah, I got a little bit distracted there. Yeah, we'll get the string, and we have to let's create a helper function. um, or what we can do is before plus dot split on dot, and then join everything together. Yeah, we can just simply do this, and we can set local equals to this, and else we can simply do this also here, or we can just do this local dot split on the basis of this and join. Okay, once we have that with us, once the local is ready, we can final email, let's call it let final email is equal to join these both strings, local and and at the rate domain. Yeah, let's join this, and map dot set. I guess we need to use a set instead of a map. Yeah, set 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 dot add final email, right? Yeah, once we do that, I'm sure there might be some mistakes in the substring, how I'm selecting the substring, so we need to probably debug it. It might not be correct or it might be correct, but yeah, set dot size is not a function. What is the yeah, it's a property on it. Okay, cool. Okay, so that works. That works. Okay, that basically works. So I was just worried if it will work or not. Okay, so we beat 99.50%. Cool. So the time complexity of this would be, anyways, we are traversing the entire emails, so that is n, number of n. Then I'm not sure index of, how much index of takes. I guess it might be searching linearly, so max of local, which is m, n into m. Yeah, so let's say it goes n. Okay, have we solved this earlier? Yeah, okay, so it wasn't solved by me at any time, but it was, yeah. uh, okay, so we have solved this one. Let's see how many companies. Twitch, why does Twitch likes to ask this question? I'm not sure. Twitch, Intuit, Amazon, Google, Wix, but it was 1 to 2 years back. Okay, anyways, we'll add this to what this, I'm not sure how the okay, the star doesn't work properly. someone needs to report this bug or something. I'm not sure. Fix this bug, LeetCode. Fix that bug. So let's go. Let's checkbox this one, and okay, we are at 199th question. So why don't we just push ourselves a little bit more and solve this isomorphic strings as well, and then probably we can shift to the React side of it and try to solve some React questions from Great Frontend. Yeah, we'll do that. Let's do this isomorphic string. Hopefully we can solve this. I'm not sure how much time has been passed. So 30 minutes, right? I guess I've solved the questions probably in 15 minutes, both of them. Cool. So they both are easy. I know that, but yeah, it's good for warming up and staying focused. Okay. Okay, isomorphic strings. Isomorphic. I'm not sure. Isomorphic. Given two string s and t, determine if they are isomorphic. Two strings s and t are isomorphic if the characters in s can be replaced to get t. All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. Egg, add, foo, bar, paper, title. So I did not understand this question. Let me read that again. Let me start the timer for this one. Given two strings s and t, determine if they are isomorphic. Two strings s and t are isomorphic if the characters in s can be replaced to get t. If the character sorry guys, I'm getting a call. Let me mute that for a while. Okay, that was a spam call. But anyways, where were we? Yeah, two strings s and t are isomorphic if the characters in s can be replaced to get t. Okay, yeah, if the characters in s can be replaced to get t. All occurrences of a character must be replaced with another character while preserving the order of characters. True. No two characters may map to the same character, but a character may map to itself. How, like, okay. So there is a egg, and we can replace a d t for this one, and foo bar is there. Why the foo bar is okay? No two characters may map. No two characters may map to the same character. Okay, got it. Got it. Got it. So I guess first of all, so the gist of this question is we have to basically create string t in string s, like yeah. Okay, so that's what I understand from this question. All occurrences of character must be replaced with another character while preserving the order of characters. Yeah, yeah. So basically, A will, yeah. Let me get my thoughts straight for this one. So S T is there, right? So what we can do is we cannot randomly place start placing the characters A of T in S, but we have to go sequentially. A here, the A will go on the 8th position. I'm not sure if I can use this enable to draw, but yeah, this is pretty small. I cannot use this feature here. Okay, anyways, so yeah, A will go to the E and D will go to G, and G will be again replaced by a D. So this is true, this is isomorphic. And um, and if we look at the second example, here F is replaced with B, O is replaced with A, but the next O is getting replaced by R. So that's where the problem comes, and it says this is not fair. Like I was replaced, O was replaced earlier with A, but now O is replaced by some other character other than A, which is R. So this is not isomorphic, so that's why we return false. Let's see the third one. PAPER is there. So P is replaced with T, A is replaced with I, P is again replaced with T, L is replaced with E, R is replaced with E. Okay, yeah. So basically the first edge case would be if S dot length is not equal to T dot length, then return false. Yeah, that is the basic edge case that we can think of. And I guess we'll need a hash map for this one. Yeah, I will maintain that map, or let's call it const. Okay, yeah, once we define the map, what we need to do here is, let me just enlarge this so that we have more room for writing our code. Yeah, once we have the map with us, what we have to do is if map, okay, I was just writing for the sake of writing the code, but yeah, let me think. I need to traverse both of the strings, right? So I know that I have let I is equal to 0, I is less than s dot length I plus plus. I know that this is there. So what I'll do is if map dot has the s of I, if we have already set the s of I, then what will check if map dot get s of I equals to t of I. If they are not equal, let's say, okay, if they are not equal, we'll return false. Okay, yeah. And what we gotta do is else if map dot we haven't seen this, then map dot set s of I with t of I. We'll set this with s of I, t of I. So E will be set with A, G will be set with D, G will be again, as G is already there, we'll check if they are not equal, then yeah, it will be returning false. And at the end, what we'll do is we'll return false. Okay, yeah, we'll return false. And once we have returned false, what we can do is, okay, once we yeah, let me also try run through this one. Foo and bar is there, F will be replaced with B, O will be replaced with A. As O, we have already seen it earlier, we'll check if the current element of T is equal to the O's earlier replacement, which was A. But yeah, in this case it's not similar, so we'll return false. So I guess that should work pretty easily. Okay, the case is wrong. Did I return false? Oh yeah, I should have returned true in the end. Okay, my true. And let's try to run this. This should run. Let's submit this. It should work. It should work. I know. Okay, it did not work. Let's see. Let's see where we went wrong. B A D C. B is replaced with B. A is replaced with A. B is replaced with D. Oh, D is replaced with B. Okay, and C is replaced with A. Let me see if I have not read the all occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character. Okay, wrong answer. If I guess they should not be similar. Use this test case. I'll use this test case. I guess uh, we have to also check if s of I is equal to t of I, then we have to return false. In that case, let me just run this. Okay, now it's a false and true. Am I not understanding what is going on here? All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. So in this case, in the BADC, output is false. Yeah, expected. So B can be mapped to A can be mapped to A, D, so looks like A was already been used. A was already been used for something else. So should we store t of I? Should we store t of I instead of s of I? I'm confused a little bit. So let's try from the first one, EGGADD. If A, I store A with E. Okay, I assign A to E, then D to G, then D to G. Okay, this is okay. I assign B to F, then A to O, but R comes in, and okay, yeah, I guess I should be setting it to both. Um, map of map. Should I also create a map of T? I guess I have to create map of T as well. New map. And what I'm thinking is, if I found a match in either of them, then yeah, I guess I have to return that. So in this case, I have never seen C, but if map of T dot has dot has so B was assigned to B, A was assigned to A. Yeah, here B is again assigned to T. So here the problem comes. Um, so if I have already assigned has T of I and map of T dot get T of I is not equal to S of I, then return false instead of doing this, so that submissions, let me go to the submissions. Okay, use this test case and run this. Oh, sorry, I haven't added map T dot set T of I and S of I. Okay, so if I run this now, it should work. It should work. Yes. Okay. Yeah. Yeah. It was a tricky one. But a slight change using two maps solved this problem. But a good question. It kind of got me. 16 minutes into it, it almost got me. I was kind of straight away jumped into the solution. So yeah, and a good amount of companies have asked this question. So pretty important question, isomorphic strings, right? Yeah, let's tick mark this one. And here we go, we have completed 200 questions from the 450 questions. Good, nice achievement. um, okay, after this, I guess we have been doing almost for an hour. We have been doing this. What we'll do is now we'll take a break, and after the break we can continue doing some React based questions. So yeah, we'll do some React based questions that should give us a good head start for those. But yeah, like I was kind of scared today. I don't know. Yesterday itself, I did array and hashing question. I should have been doing today 2 pointers, and all of them were medium. So I guess I got scared there. But anyways, I'll see to it that I